Hi and welcome to Algebraic Proof. Just before we start, a quick reminder that there is a notes jotter available for this video. Just check the description below for a download link and you can work along with me as we go through the video. So just before we get into the concept of algebraic proof, I just want to go through some keywords which will crop up throughout different questions on this. So if you are asked for the sum, that means that things are added. If it is the difference, it means they have been subtracted. The product means they have been multiplied, and the quotient means that they have been divided. So we're going to begin with 5 terms here. We want to look at consecutive integers. Now this is algebraic proof. So how do we show that we've got consecutive integers, i.e. one whole number after the other? Well, the idea here is that we don't know where we have started, and therefore the first value we would just call n. And so this is the number where we began. So what would the next number be called? Well, the next number is 1 higher, and so the next one will be n plus 1. And the one after that will be n plus 2. And this could go on forever and ever. But also, we could go backwards. So if we have our first values being n, well, the value previous to that would be n take away 1. And we could go the same backwards. We could keep going into the negatives before that. What would we call even integers? Well, what does it mean to be an even number? Well, it means that it can be divided by 2. And therefore, it means it's a multiple of 2. And so the very first value that we have, we would call 2n. Because that means that no matter what, that first value is in the 2 times table and therefore is an even integer. Beyond that, what would the next even integer be? Well, the next even integer, if we think about consecutive even integers, we'd start with 2n. Well, the next one would be 2 later, so 2n plus 2. And after that, 2n and then plus 4. But if we went backwards, we could say that the even number before 2n was 2n take away 2, and before that 2n take away 4, and in both directions that list could continue infinitely. So what would we call an odd integer? Well, that means it can't be even. So if the even numbers are 2n, well, the odd integer would be 2n plus 1. It'd be 1 more than an even number. And so the one after that, if 2n plus 1 is where we started, well, the one after it will be 2n plus 3, and 2n plus 5, and so on and so on. But again, going backwards, if I was to go the odd number before that, well, it would be 2n take away 1. It'd be 2n take away 3, and so on in that direction. So now we come to the actual proof. We've been asked to prove that the product of an even number and an odd number is always even. Now, there are some keywords here. The first one is prove. Now, prove means you must use algebra. If you just put some numbers in here and give some examples, so 2 times 3 or 4 times 7, that would be evidence that it is always even, but it would not be proof. Proof means that it must work for all possible values. We then have the word product, and so because it is product, that means we are multiplying, and we then have that it's an even number, and so even numbers are things that we call 2n. And then the odd number, well, because it's going to be slightly different, I'm just going to, with it being an odd number, this time I'm going to call it 2m, and odd numbers are 2m plus 1. And the reason I've gone with 2 different letters is that these numbers are not necessarily one after the other. They could be separated by very large amounts. It could be 2 and 101. They are an even number and odd number, but they wouldn't be related to each other. But what it's asking is for us to prove that this is the case. Therefore, what I'm going to do is I'm going to take my even number, 2n, and I'm going to multiply it by my odd number, 2m plus 1, and I'm going to pop that in a bracket, and I'm going to see what the result is. So 2n times 2m, well, that would give me 4mn, and 2n times 1, well, that would be plus 2n. Now the question is, how does this show that it is always even? Well, there is a very simple trick. If you want to show that something is always even, what you need to do is you then need to factorize your answer to show that it is in the form 2 brackets. If it is 2 and then an expression inside of the brackets, that means it must be an even number. And let's have a look. Can I factorize this one? So it's just 2 brackets. Well, a factor of 2 here would give me 2n, and it would give me a factor of plus n. And therefore, because we've managed to factorize it to be 2 brackets, that shows it will always be even. We then want to prove that the sum of any 3 consecutive even numbers is a multiple of 6. So again, we have that word prove, means use algebra. We have the word sum, and so because it is sum, it means we're going to add together. And then we have 3 consecutive even numbers. And so if we're going to deal with 3 consecutive even numbers, we can do it by starting with the first even number, 2n. We want a value which would go after 2n. So the next consecutive even number would be 2n plus 2. But also the one before 2n will be 2n take away 2. So those are my 3 consecutive even numbers. But it says that we want the sum of each of those. So if I do 2n take away 2, and I add 2n, and I add 2n plus 2, what do I get? Well, if I simplify that, it's 2n plus 2n plus 2n is 6n. Negative 2 plus 2 is 0. So this is actually just 6n. And this is my proof that it is a multiple of 6. Because all this is saying is it's 6 times something. 6n is the 6 times table, just as 2n is the 2 times table. Next, prove that the difference between any 2 consecutive square numbers is odd. Well, again, we have the word proof, so we need to make sure that we use some algebra. We have difference, and so we have difference being subtraction, and any 2 consecutive square numbers. So how would we show that we've got a square number? Well, the first square number we would have would be n squared, as in this could be 1 squared, 2 squared, 3 squared. What would the next square number be? Well, the next square number would be n plus 1 all squared, because that is saying if n was 2, this would be 2 squared, and if n was 2, then the next one will be 3 squared, and so on. And so it's asking us for the difference. Now, obviously, this second one is going to be larger than the first one. And therefore, I'm going to say n plus 1 squared is going to take away n squared. And so what we need to do first, we need to actually expand this so that we can get the exact answer to it. So n plus 1 squared, well, that's going to give me n squared plus 2n plus 1, and we're going to take away n squared. Well, if I do that, n squared take away n squared is 0, and so it leaves just 2n plus 1, and we were asked to prove that it will always be odd. Well, what we've ended up with is 2n plus 1. 2n plus 1 is the form of an odd number, and so we've managed to show that the difference, no matter what those square numbers are, the difference will always be an odd number. Our next example is slightly different because this time we've been asked to prove that the expression 2x plus 1 squared take away 2x minus 1 squared take away 10 is never a multiple of 8. Therefore, what we're actually trying to show here is that it doesn't work as a multiple of 8. So the first thing that we're going to have to deal with is the fact that we have an expression with squareds in here. And so we're going to have to expand all of this out so that we can simplify the expression as much as possible. And so if I have 2x plus 1 squared. Well, 2x plus 1 squared, that's going to give me 2x times 2x is 4x squared. It's going to give me plus 4x, and it's going to give me plus 1. If I do 2x take away 1 squared, well, that's going to give me 4x squared take away 4x plus 1. And so then if I fill in everything that we have here, that is 4x squared plus 4x plus 1, and then we are subtracting this entire expression. So we're taking away 4x squared, but we're actually adding 4x and then taking away 1, and then at the very end we're taking away another 10. And so if I want to simplify that expression, 4x squared take away 4x squared have cancelled each other out. 4x plus 4x gives me 8x, plus 1 take away 1, well, they've cancelled each other out, take away 10. And so the question here is, how do we decide that this is not a multiple of 8? And so it comes from the same situation as we've had previously, where we want to factorise. If this is going to be if this is going to be a multiple of 8, then we should be able to write it as 8 brackets. So in this case, if I did that, it'd be 8 brackets x. But the take away 10 can't be written like that. It would have to be 8x take away 1, but then I would have to take away another 2 afterwards. 8 times negative 1 is negative 8, but I would need another 2 taken away. And so what this is showing is that this piece is a multiple of 8. But then, because we are taking away 2 afterwards, it is no longer a multiple of 8. And so, not a multiple of 8, because we are subtracting 2 at the end. And finally we come to prove that for all values of x, that x squared minus 6x plus 17 is always positive. Now for this one, it all comes down to our manipulation of this expression. We've got x squared take away 6x plus 17. Now usually what we would like to do straight away is to try and factorise an expression like this. But the problem is here that x squared minus 6x plus 17 does not factorise. And so the only other option we have here is to complete the square. And so completing the square tells us that we should halve this value of x. And so we've got x take away 3, and we're going to square that. And so x take away 3 squared, well, that would give me x squared take away 6x plus 9. But we need it to be plus 17, and so I would have to add 8 at the end. Now, what this is saying is that what we need to think about is, how do we show that this means it will always be positive? Well, the key comes from this. If I have something squared will always be positive, no matter what. And so even if this answer inside of the bracket had been negative, so if x was 2, this would be negative 1. But once we've squared it, it will always be positive. And so then I've got a positive value plus 8. And so because we have a positive value with something added on, this must also be positive. And so the proof is actually just coming from the fact we've managed to complete the square with a positive value at the end. And so we end with our exam question. It came from the Edexcel paper in June 2018, and it was on higher paper 1. And it says, prove that the square of an odd number is always one more than a multiple of 4. And so, prove, you need to use algebra, square of an odd number. So the first thing we need to do here is we need to write down an odd number. Well, an odd number would be 2n plus 1. But it is the square of this, and so all of that must be squared. And so if I square 2n plus 1, well, I get 4n squared plus 4n plus 1. And we've been told to show that it is always one more than a multiple of 4. Well, what does a multiple of 4 look like? Well, a multiple of 4 looks like 4 brackets. And so if I put 4 brackets into here, I've got 4n squared plus n. That would give me 4n squared plus 4n. And then we'd have 1 added on at the end. And therefore, 1 more than a multiple of 4. We have proven that it is the case.